Ah, thanks. Muted again. Yeah, I don't know what happened. It just I don't know what's wrong with this my system. It just crashed again. Maybe I compiled a new OBS version. Maybe it's related to that, or I don't know. That's so annoying. Whole computer gone. Had to reboot. So yeah. So let's open up code again, and hopefully this will not trigger another crash now. So code starting. Yeah. So yeah, the frontier request server. So that is the class we want to bring to Rust, and let's switch to the CPP file. And where is it? Down here, the request server. So this is the constructor. Then we have a send next method that does some stuff. We have a send finished that does something, and we have a no block send action next, and send confirmed. So not that much code, but it uses threads, which makes bringing that to Rust a bit more difficult, but not impossible. So yeah, let's just begin by going to the Rust site, and let's create a new file for the frontier request server. LF, welcome back. Yeah, my system crashed again. So let's create a new file in Node, Bootstrap, and yeah, this is the right place. So let's create a file and call this frontier request server .rs, and we need the same thing in the foreign function interface, the FFI part. So this is the part that translates between C++ and Rust. Also, it should have the same structure. Yeah, here, Bootstrap. So let's add a new file, and we call this one frontier request server 2. And here it is. Let's add it as a module. Frontier request server. And oh yeah, the other one I have to add as a module too. In here. Up here, let's add it. On frontier request. So LF says, can't wait for Nano to moon so you can get a better laptop. Yeah, I promise. If Nano moons, I'm gonna buy a better laptop. Okay, frontier request server. So I want to create just an empty struct in here, and so struct frontier rec server, and let's give it a new method. Generate new. And on the FFI part, we need, again, like I always do, like two functions, one for creating the frontier server and one for destroying it. So extern C frontier right. And this will return a handle, but we have to define the handle first. Frontier rec server handle. And the frontier request server handle contains a frontier rec server. Why is it not visible? Oh, I think I have to make this one abuse, maybe abuse. Maybe we can find it now. And here, request server. There it is. And we return just a raw pointer to the frontier request server handle. And we do this by creating a box into raw, box new, frontier request server handle, and in that we create a new frontier request server. So this is the usual stuff I do to create instances of Rust structs from C++. So the second part is destroying or deleting that raw pointer again. So for that we create a function called rsn frontier request server destroy, and it takes the handle, the raw pointer handle to the handle, and it just drops the memory. So drop box from raw handle. Okay, so these are the first two functions we need: creating an instance of the request server and deleting the instance. And we can just incorporate these two functions immediately into our C++ implementation of the frontier request server by giving it a new field with our handle. So that's frontier request server. Is it in the code completion already? Yeah. Frontier request server handle pointer handle. And this one we can initialize in the constructor. So let's do that here. Handle. Handle is rs nano rsn frontier request server create. So this creates the handle, and we need a destructor. Let's add a destructor here. And in the destructor, we have to delete the Rust instance. So let's call rs nano rsn frontier request server destroy, and we pass our handle to destroy. And so usually I also delete the copy constructor, because this cannot be copied. This would lead to memory issues if the frontier server would be copied, because that would lead to a double free of the handle. So let's see if we can just remove the copy constructor. Server. Ooh. Delete. And I think this should be okay, because I don't think the frontier request server gets copied anywhere. So LFLF says you can change the VS Code setting Rust Analyzer check command to Clippy to get Clippy warnings directly integrated within Rust Analyzer output. Really? Let's try. In the Visual Code settings, let's see. Rust Analyzer. The Rust Analyzer check command to Clippy to get Clippy warnings. Where is the check command? check command here. Cargo command to use for cargo check. So 1 billion trader, hey, welcome back. You said, your stream came on and then Nano pumped. Where is the pump it? Oh, this has nothing to do with me. I wish I could. So check command, yeah, let's set the check command to Flippy and let's see if that works. Did it pump? Where's, let's have a look. What's the price? $0.62. Oh, and it was at 64. That's nice to see. And trading volume went up too. 125,000 nano. So this is just Kraken. So this is not all of the exchanges. This is just Kraken. Cool. Okay, so we created an instance in the constructor. We deleted the instance in the destructor. And now we can, let's see, what do we have here? These are all the fields, and we have to move all of them to the Rust side. This will not be possible. We cannot move a node pointer, a weak pointer to Rust. We have to find out what this class actually uses and then just move the parts that it actually uses to Rust. It has a shared pointer of the TCP server, account, block hash, unique pointer, frontier request, and a double-ended queue for the accounts. So where to start here? Where to start? Should we... Maybe just... So I'm thinking, because this is not much code, we could just bring all of these fields to Rust and then move the implementation all at once. Maybe a bit risky. The safer way would be to move it all one by one. And so if we move the connection, that we then use the connection that lives on the Rust side, that we use that one in the C++ code, and that is a lot more work, but it is safer. So I just want to have a look at the code again. Like, how hard is it? How hard is it to move all of that to Rust? Should we take a risk and just move it all at once? I am inclined to take a risk and because usually I do this in small steps and safe steps, and then I know nothing goes wrong. And if we take larger steps, then it's risky, because we could like end up in a mess. And it could, because what do we do if it doesn't work? Like, if we moved all of that at once and then for some reason it doesn't work, then finding the error is can be a sad task. So LFLF says, make it risky, make it more exciting. yeah, you know how it will end up, man. I'm just going to end up in trouble. Underflow says, it's Rust, move it. Yeah, okay. So if it doesn't work, then it's on you guys. Okay, let's try. So let's do it all at once. So let's move the TCP server. So the TCP server has a Rust handle already, so I think we can just where is the constructor? We can just add it as a parameter in here. So we can just say connection dot handle. Yeah, and it's a TCP server handle. So let's add the TCP server handle in here. TCP server is TCP server handle. And we are going to dereference this, so this has to be unsafe. So our Rust implementation needs an arc. No, it is called connection, yeah. Connection is an arc TCP server. Or is it an arc or an arc mutex? It's an arc, I guess. So it has to take the connection. Connection, we need that in here too. So let's put it here too. LFLF says underflow gets it. Yeah, it's Rust, move it. Yeah. So we have the TCP server on the Rust side now. The next thing is, yeah, current and frontier. That's account and block hash. So let's add that here too. So current is an account and frontier is a block hash. Let's use account. Oh, now it doesn't show any errors. Is that because I changed it to Clippy? Because I have not imported block hash and it doesn't. Maybe there's something wrong with the Clippy thing. Let me disable that again. So there was Rust. What was it? Check command. Let's add it back. Let's change it back to check. And if also that's LF's fault. Let's see if the errors come back. Yeah, there you go. Here they are. So arc. So what should we initialize current and frontier to? Frontier is 0 and current is... Oh, we get that from request. So we need but request we only use... No, here's the request. LFLF works on my machine. Yeah, that's the famous saying of all programmers. Works on my machine. So we need to set current to account 0. And we need to set... Yeah, no, frontier is 0. Current, we have to set current from request. So let's set frontier to 0. And we have to set the current from request. So let's add the request here. What is the request? The request is a unique pointer to... Oh, went away. A unique pointer to frontier request. The message frontier request. And can we add it in here as a frontier request too? How is it on Rust? Let's see, frontier request. Frontier, oh, it's a struct frontier request. Okay. And do we have a frontier request handle? RSN message frontier request create. Oh no, I didn't want to go to the header file. Frontier request create. Here it is. So this returns... Oh, we just have a message handle. And what is a message handle? It has a boxed-in message. But I think we can downcast the message to... Yeah, we can downcast the message to whatever type we need. So let's try to write the code in the same way it is as in the C++ part. Just closing some files. Here, messages, CPP, and this one, and this one. So in here we have a shared pointer, no, a unique pointer to frontier request, and we store the unique pointer to frontier request here. Maybe we don't even need a pointer in Rust. Maybe we can just directly have a structure. Let's try. So request. Oh, what's it called? Request? Yeah, it was called request. It's a frontier request. And we need that up here. A frontier request. And then we set it here, request, and we have to initialize current with request get start dot number -1. Okay, we can do that. So we can say request dot start number. What does number return? U256 -1, and we have to convert that one back into an account. And I think this is buggy. At least on Rust, this can panic in Rust, because by saying -1, let's say the request start is 0, and we say 0 -1, and this would overflow or underflow. So in C++, I think it would just wrap around, but Rust is different here. Rust will actually panic, and we don't want to panic here. So we could write this code that it would behave in the same way as the C++ version by saying wrapping. Does it have a wrapping? No? There's no wrapping add or wrapping checked. What is that? Oh, a checked add returns an option. There's no overflowing. Oh, it's called overflowing. Overflowing add and overflowing sub. Just checking what it does. Subtraction with underflows and returns a flag if it does. Okay, so this is... No, this is also not what we want. Is there no wrapping add or wrapping sub for U256? Saturating add and saturating sub. What does the frontier request, what does this message contain? So it says, I want to request frontiers, and I say this is the start account. And the count is, I guess, how many frontiers I want to get. What is this age? I have no idea. LF says, why doesn't overflow sub work? Doesn't it just wrap around and tell you if it did? Does it wrap around or doesn't it? I'm not sure. Overflow. What does overflow sub do? Subtraction with underflows and returns a flag if it does. So does it? So okay, yeah, you're right. So it does underflow. and we don't care about the flag because the C++ code doesn't care about this either. So my guess is if we would receive a frontier request message with current set to 0, then maybe we would not get any responses because it would overflow or underflow. It would underflow and then I don't know. Let's just port all of the code and then we will figure this out. So let's add a comment here to do figure out what underflow does. And let's do an overflowing sub of 1, and we want to just take the result. And this takes a U256. How can I... This U256, where does this type come from? .256 primitive types. So this is from a crate. How to create that? Is there another from? Oh, yeah, no, let's try it like I did there. Where is that just 1 and 2. Okay. So we have the current. Yeah, that is a difference between the Rust code and the C++ code that bit me a couple of times, where C++ does just happily overflow and underflow, and nothing happens, and Rust panics. And yeah, I ran into that a couple of times already. So now I'm a bit more careful whenever I see a -1 or a +1. I think about can this overflow, can this underflow? So okay, let's see what else do we have. Oh, sorry, I'm looking at the wrong place. Here we are. So we have the current, the frontier, the request, the count is a U size. And we initialize it to 0, I guess. Let's see. Or the count, yeah, we initialize count to 0. Then we have a double-ended queue of pairs of account and block hash. So let's add, maybe can we just move that window down here? And then I don't have to switch the windows so much. And then up here we go to our Rust code. Let's close this. Here. Yeah, much better, I guess. So let's add the double-ended queue accounts. In Rust it's a backdeck, and our type is a tuple of... Is it tuple or tuple? How is it pronounced? Tuple, I guess. A tuple of account and block hash. Then what else do we have here? Frontiers. Oh, I have to initialize it. Accounts is that new. counts. So there's no initialization here. So I think it's just, yeah, default, which is just an empty queue. Frontier request server create. Requests. Did I close the header file? Yeah. So let's go back here. Oh no, the header file is below. Here it is. Okay, accounts. Frontier's age is a U32. And count limit is a U32, and we initialize both to max. Like that. And that's it, I guess. No, what's that? We missed. Oh, that was the wrong class, chat. Oh man. This is the correct class. So we have count, accounts. Yeah, we don't have Frontier's age and count limit. The only thing that we don't have in Rust now is the weak pointer to node. So let's find out. Let's find out what this is used for. So we have the initialization up here, and then in the send next, we use the node to use. So we access config, which is node config, and logger. So safe to say that we need the logger in Rust. Logger is an arg bin logger. What else? So the config is, yeah, node config. Let's also add the config here. I think it's an arg2 node config. So this is all not very idiomatic, Rust idiomatic, using args everywhere, but it enables us to port stuff step by step to Rust. And once we have everything on the Rust side, I want to get rid of all of these args and use the borrow checker instead. Yeah, so config and logger. Let's go to the next function. What do we send finished? It uses again config and logger. Next function, no block send, uses config and logger. And send action uses bootstrap workers. So this is a thread pool. Bootstrap workers is a thread pool that is just being used by the bootstrap code, and that was a change that I think Piotr made recently, where before we had one thread pool for all requests, and now there's a split. Now there's an extra thread pool for the bootstrapping part and another thread pool for the other stuff. And that's a good idea, because the bootstrapping can get expensive, and so it should not block other requests. So bootstrap workers is a thread pool, and I want to have a look at the other bulk pool server, because I think this also, yeah, uses the thread pool. So let's copy that into our struct here, thread pool, and this has to come from up here as an argument. I really don't like that if we have to pass like so many things, but let's just port it as that, and let's clean it up later. Or this I won't clean up actually. This is the code I hope that will go away. So I won't invest any time in cleaning that up. So yeah, thread pool. Thread pool is arc, then thread pool. Thread pool. What else? Oh, we are missing all of them. Logger and config. And let's also put them down there. Logger config. Yeah, because like if functions have so many arguments and there will be more even, then it's just really tough to work with the code and to remember all of the arguments, and it just is messy. Bootstrap workers. So let's search for more. I want to take a small giveaway break. Chat, let's do another giveaway. So if there are any new viewers who want to take part in the giveaway, just quickly post your Nano address in chat, and with a bit of luck you will get 1 Nano. So these are the participants for today. Just post your Nano address and you can win 1 Nano. But I think there are no new viewers in the chat, so let's do this now quickly. So again, 5, a random number between 1 and 5. 1, 2, 3, let's click it, and the number is 5. So congratulations to Neil Woodham getting another Nano, because he got one. He got one that I wanted to send to LFLF. So let's copy your address and send you another one. 1 Nano. Here you go. So back to the code. So yeah, we have the thread pool, the bootstrap workers, we have the config, the logger. Then down here oh, okay, this is more interesting. We access the store. And for stores, I don't pass the store around currently, so I always pass the whole ledger. But the ledger is actually, it's actually the same as the store. It just has a little bit of more code in it, but it's the same thing. So let's pass the ledger to Rust as well. And then we're done with all the dependencies. So ledger is an arc ledger. Ledger is an arc ledger. Ledger. Okay, we have all of the dependencies in Rust. And we have to add this now to the foreign function interface. All of the arguments. Because here it complains already. It complains that... Where is it? No, not here. Not here. Here, the FFI parts here. We have to give all of those arguments here. So the connection... We have the connection as a TCP server, so let's say TCP server. Let's dereference the raw pointer. .0.clone. So this gives us an arc TCP server. The next argument is the request. So the request we have to pass that as a message handle. Can we say const message handle? And then we have to downcast the message handle to... Let's go to the code again and let's see how we can downcast this to... Downcast message takes... Oh, it takes the raw pointer. Then let's do it like that. Let's say downcast message. And we give the message handle the request. And we would want to downcast it to a frontier request message. And this returns what? A reference. A reference. So let's clone it. So cloning means copying, which is wasteful. But I really don't care about the speed of the FFI part because all of this is just temporary code. So spending time optimizing that would just be wasted from my point of view. Is chat broken? I haven't got any. Could you just like type something in chat? Just a test message, because I have the feeling my chat window is broken. Ping, yeah, okay, sorry. Okay, no, then everything is fine. So we have the frontier request message. What's the next thing? We need the thread pool. How did we pass the thread pool in the bulk pool server? Oh, there's just a handle. That's good. Oh yeah, I remember. Like the thread pool, it was implemented on the C++ side, and a couple of weeks ago, I switched to a Rust implementation of the thread pool, and now all thread pools are actually managed by Rust. So, thread pool, and that means we can just easily use them. So let's dereference the thread pool handle. And what does it contain? Oh, we have not included it here. An arc thread pool impl. Arc thread pool impl. Okay. Expected. Oh, it has to be mute. Oh, that's bad. Let's change it to mute. Doesn't make a difference in this case, but yeah. Thread pool. And what else? The logger. Let's see. Let's just peek at our pull server again. It also has a logger. Oh, logger handle. Oh, yeah, I remember. I refactored that too. Logger. No, what's that here? Arc logger, arc new, logger MT. What is logger handle? Okay, this is just a raw pointer. Okay, let's just copy that to the logger. Let's copy the logger too, and let's also copy how we instantiate a logger from the raw pointer. So like that. And then we can give the logger here. Next thing is node config. LFLF says, I think it works. Oh, my question before here. LFLF says, do you have any plans to add comments and documentation? Oh no. Yeah. You are right. So I should write more comments. And sometimes I do. And I think comments are important in a way. So there are good and bad comments. Like if the comments just repeat what the code says or code does, then those comments are just useless. But good comments explain, yeah, why we do the things we do, or they just summarize it, or they give deeper insight or knowledge that is not directly visible from the code. And yeah, I should write more comments. But writing comments is hard, and also it's not fun. So that's why, yeah, I have the tendency to skip that. But yeah, you're right. Trying to remember that. But so actually, so during the porting process, like what I do right now, I just like move the code over like how it is, and I don't have a good understanding of it yet. So I wait until I have everything ported, and then until I have understood everything, and then would be a good time to add comments. Server new. Yeah. Logger. What was it? I wanted to add the config. Node config. So let's copy that from the bulk push server 2. No, oh, this one doesn't have a node config. Okay, then let's add it here. Config. Node config. DT. Oh, so this is not a handle. This is just a data transfer object. And how can I make a node config out of that? Into? Can I just say config into? But this will not create an arc, so I think this doesn't have to be an arc. Then the node config can just be a node config. I think this will be moved out anyways, because I don't think we will use many things of node config. Node config is the configuration for the whole node, and I think we will just use maybe one or two things from that config. And so usually I just refactor that to not be dependent on node config and to just have a dependency on the one or two things that this class actually needs. So next thing is the ledger. Ledger is an art ledger. So let's add the ledger with the ledger handle. LF says, I know comments suck, but they could be helpful sometimes. I understand your point though. Yeah, no, yeah, I think they are helpful, and they are, yeah, as I said, like there are good comments and bad comments. Like the worst thing is comments that lie to you. Like when they were written, they were true, but then the stuff got refactored and the comments, they tell a different story than the code. So that is dangerous, but also unit tests are a good way of documenting what the code does. So if you have like a small readable tests with good examples, then unit tests can also be a source of documentation. But yeah, you're right, like you are right. I should add more unit tests for me and for others who want to help. And yeah, and like I said, also for me, because when I write stuff now, of course I understand it and it's in my head, but like 3 months from now, I have already forgotten it. Yeah, and I think that's a normal thing. That's just the way our brains work. So ledger, let's add the ledger. Clear. And I think that's okay now. It doesn't show any errors anymore. There's something down there, too many arguments to function call. Yeah, so here there's something wrong here. Mismatch types. Okay, so this has, we have to remove the arc. What is wrong here? The trade bound from node config DTO is not satisfied. What conversions do we have configured here? Try from, so this can fail. Okay. Then let's say try into, and we just unwrap it because this should not fail at this point. No, it still doesn't work. Oh, it has to be a reference. Okay. Then let's borrow it. Looks better now. Okay. So now that we have all of these arguments in here now, let's provide them. This should not fail. Famous last words. Yeah, so usually I'm more careful with unwrapping, but as I said, this is just glue code, temporary code, and so if this panics converting the config DTO to a node config, it should have panicked way earlier, because I know there are places in the system that we call way earlier than this that do the exact same thing, just converting from the DTO to a node config, and then so if it would panic, it would have panicked already. So that's why I said this should never fail. But you're right, yeah. We can be wrong about that easily. So okay, so now we have to provide all of that here. So does this code completion help? No. Oh, it doesn't show what we have here. Let's go to split screen mode again. And let's move the Rust part below. Here it is. So these things we have to give it now. So the TCP server, the connection is there. And the next thing is that the request. So let's say request a handle. The next thing is the thread pool, which is node a bootstrap dot. And the next thing is the logger. We get that from the node 2. Node a logger. Handle. Oh, does the logger have a handle? No. How to pass the logger? Is it just the logger? I want to. Where can I check that? Can I check that in the bulk pull server? How did I do it here? Bulk pull server. Bulk pull server. Account client. Bulk pull server. Oh, wow. You found it. To logger handle. Yeah, I remember now that you say, now that I read it, you're right. There's a conversion function here. To logger handle, and we give it a shared pointer of logger MT. So that is node a logger, which is a shared pointer. Yeah. Thanks, man. Saved me some time here. What's wrong here? No member named 2 in namespace nano. 2? No, okay, that was not an error. So next thing is the node config DTO. So that is node A config. And this is, what is this? Also a shared pointer. Does it have a, yeah, a 2DTO, but... Oh, yeah, this is so annoying on C++. This will not work because I can't take... Well, I think this won't work because I can't take the address of a temporary object here. Next thing is the ledger handle. So that's node ledger and get handle. And that's it. Yeah, as I said, we can't take the address here. We have to we have to have a local variable called DTO, like config DTO, and then we can take the address. And I don't know if there's a better way, but usually what I've done in the past is I've just created a helper function, and I've called that like create frontier request server handle, and this would return, what would it return? This one, it would return a nano, Ars Nano frontier request server handle. Server handle. And in here I would just do that. Return. And then we can create the DTO up here. This is, what is it, an Ars Nano node config DTO. And then we can take the address of that DTO down here. But that means I have to duplicate all of the arguments here. And that's just annoying. Like a lot of duplicated stuff. Chat, do you know if there's a simpler way to do this? Oh, I have to give it a name. DTO or config. Config DTO. Config DTO. And then we can just call it here. We can say create frontier request server handle. And we give it, yeah, a connection, a request. Oh, we could just, yeah, just a node. No, I made that, that was wrong. I should copy this one here and move it up here. Like that. LFLF says, I'm super confused by CPP. Can't help either, sorry. I get confused by CPP too. So connection, so node, no, node was the first. Node, connection. And what's the next one? Node, connection, and request. So, no? Oh, this was a unique pointer and it was moved. Yeah, then let's say, then let's just take the message handle. Current Wait a second, not current, request. Request, message handle. So the request, we just say RS Nano. Message handle. Request A. And then request A is the handle already. And we can just pass it like that. So, okay. Good. I think that's okay. Let's reformat the code. Let's compile it. So let's reformat everything. So cargo. So this reformats Rust code. Let's reformat C++ code. And let's have a look at what we changed. Want to add it? So this is our Rust stuff. Our new Frontier request server in Rust. And this is the FFI part that creates an instance and deletes the instance. This is the, our Rust implementation, which doesn't do much. Yeah. So let's run the compiler and let's hope that my laptop doesn't crash anymore, like it did before. Okay, compiling, and Henderson, Nano is the light. every stream, Nano is the light. Hey, welcome. Want to post your Nano address to take part in the giveaway? Because I want to do another giveaway while we compile. Oh no, it does. It compiles everything from the beginning. I forgot. I wanted to compile before I started the stream, so that it would not take forever. But now it takes forever. I forgot. I can't do that many giveaways. And 4%. Wow. Maybe I should not compile then. This takes too long. But let's do another giveaway. Okay, so Wenderson, do you want to post your Nano address? %. Oh, that's so slow. Wenderson, you're doing a great job. You're an inspiration to the community, and you're bringing a new community of developers. Oh, thanks, man. Oh, that's nice. Thank you so much. Yeah. So that's the reason why I want to do why I do these streams. To get people into Nano, to get people into Rust, and to share the love. Share the love for Nano and Rust. So this is Anderson. So let's do another giveaway. So now we have six addresses. So let's create a random number between 1 and 6. Ready, chat? Let's click it. And the winner is number 1 again. So that is Sammy D. Congratulations. Why did the music stop? TechnoJunkie88 says, is Nano good for embedded devs? Embedded devs? You mean like integrating Nano into embedded systems? Good question. I don't know. Well, you would have to communicate with a Nano server, so this could be done from embedded devices, I guess. Yeah. Yeah, so sorry, I wanted to send 1 Nano to Sammy D. So let's copy that address. Let's make sure it's the correct one. 1BU5. Is that Sammy's address? Yeah. So 1 Nano. Preparing transaction and sending. Done. And Defnal says, if you're not running a node on that tiny thing. Yeah, I mean, running a node on an embedded device, I think that's too much. So let's get on with it. 13% now. Okay, I'm stopping the compilation. This is just taking way too long, and I don't have that time. So let's just assume let's assume that it works. LFLF says, I think someone ran a Nano node on a Raspberry Pi. Oh, cool. Yeah, in theory, so Nano is really efficient, and it doesn't. Yeah, it should be possible to use very cheap hardware to run a node. Okay. So I'm just assuming that everything is okay here and that it works, because I don't want to spend all of the time here waiting for the compiler. So let's just do the next thing, which is, so we have all of the dependencies, so we can start with porting our first function here. Maybe the send next. Let's see which one is a good candidate. Send next calls. What does it call? Send action. So send next calls send action. So we should, and send finished. So we should start there. Send finished calls no block send. LFLF says there is a post on Reddit, but everything's private. Ah, yeah. The thing there where all of the subreddits go dark. So no block send. No block send does. So yeah, this is a good starting place. No block send, because it does only call connection.start and it locks some stuff. So this, I think this we should be able to port this easily. One last thing I want to think about is the weak pointers, because the C++ version uses weak pointers here, and this is to prevent memory leaks if the node is shutting down and there is still frontier request servers running, for example. That this should not prevent the node from being destroyed. And our Rust version does not have weak pointers right now, but on the other hand, it just has access to the ledger and the TCP connection. And I don't want to use weak pointers here because I think the shutdown should be managed by the whatever this thing is created by. Oh, underflow has shared a link. Ah, solar powered nano node, yeah. Okay. So, what to do next? Yeah, let's copy that no block send function to our Rust file, and in here, and let's just comment it out, and then we can just implement our Rust version of the same thing. So let's create that no block send. Maybe it doesn't have to be publics. Or does it? Yeah, it has to, because it's public in here too. So let's make this pub. No block send. It takes himself. And it takes an error code. Oh, wait a second. Then it can't take self. As we call this one, I think this is a callback, or is it? No, who calls no block send? Yeah, okay. Let's just copy it, port it as it is. So it takes an error code, and it takes a size. And it returns nothing. So, like that. Then what it does this weak pointer check, and we don't need that. Because we don't have weak pointer. So, what it does here is it checks the error code. So, what it checks is if this error code is okay. Then we start the connections. And if it's not okay, we do something else. So is there a start? Yeah, there is a start function. What does this return? Nothing, I guess. Ooh. No definition for start. We don't, oh, why don't we have a start function in our connection? Oh, maybe we just encountered something that we should have ported first. I thought connection was ported. Completely ported. There's no start function. Let's see what it does. No, this calls into Rust. Bootstrap server start. Ah, maybe I'm missing an import. Yeah. So this start is defined in a trait that is implemented for Arc TCP server. Oh, I was really getting worried here. Okay, so we call start. And if start doesn't succeed, we say, so if node config logging network logging, so we have to config directly. So if config.logging.network logging, this is still called value, network logging value. Hope this will change soon. Then we log, so self.logger.trylog. And here we have to format a string. Error sending frontier finish. And we have to give it the message. But we don't have the message, I think. On the Rust side, what do we have here? category. Can we just... Oh, by the way, thanks for the 5 nano donation. I just saw it when I restarted my computer previously, so thanks. Thanks a lot. So I want to just maybe debug. No. Does error code implement display? No. It just implements debug. Yeah, so this is... I'm deviating here a little bit from the official implementation because these error messages, I think they will still be useful because they will print the error code, but I just don't have access to the error message here. So I'm just printing the code instead of the full message. But I think that's okay. Okay. Size is not used. Okay. So we ported our first function here, no block send. Let's see what else we got. What else do we have? No block send is done. Send action. What does send action do? Call send next. Yeah, so there's a loop here again. There's a loop between... So send next calls send action, and send action calls send next. So this is really bad because we can't do it like that on the Rust side. We have to use a different technique. But maybe we can first port something that is simpler. Send confirmed. Yeah, this one is simpler. Let's port that one first. So this is pub fn send confirmed, and this returns cool. Self, and this returns self.request.is only confirmed present. Do we have that? Is only confirmed present? We have something with that is called is confirmed present. Is that the same thing? It's the same thing. Is confirmed present. So we got that. And yeah, so I don't want to start a huge task like porting that huge thing now. And I don't want to start the huge task of refactoring this so that there's no circular reference here at all. So chat, what do you think? Should we call it a day early and do another giveaway, or the remaining giveaways? I have 2 nanos left in the wallet, so let's do two giveaways, and let's call this a day. Yeah, let's do that. So 6, still 6 people in the giveaway. Yeah. So let's just create a random number. 1, 2, 3, click. So the winning number is number 6. Wenderson. Here's a nano for you. 1 EC. Paste. Is that the correct one? Yeah. 1 nano. Okay. And let's do the last one. So 1, 2, 3, click, and it's number 1 again. So Sammy D, congratulations for another Nano. Paste 1 PU. Is that the right one? Yeah, that's the right one. Yeah, done. Okay, chat, let's call this a day. So we worked a little bit with the bootstrapping stuff. Maybe I should have explained what this does, or did I? So the frontier requests, where we can request the frontiers, which means the newest blocks that they have, and we can then use those frontiers to synchronize our server with other servers, or we can use that to find out if we are missing any blocks. So yeah, I should have explained that in the beginning, before I started with the porting. So yeah, so we started here. We did not get very far, so basically we just create the server instance on the Rust side, and we have all the dependencies now that we need. And what's missing now is just, yeah, the actual code, the actual implementation. And but it's not that much work left, so maybe I will not work on that during this week and actually finish it on stream next week, so that you guys have a chance to see if it works or not. If our risky approach of porting everything at once will actually work out or not. Yeah, I think that's the plan. So thank you guys for watching, and the next stream is next Tuesday, like every Tuesday, from 7:30 UTC to 9:30 UTC. If there's anything in particular that you want to see, just yeah, write me in chat or write it in Nano Discord, ours Nano Discord. So there's I have a Discord server. Where is it? rsnano.com. So on rsnano.com you can find the link to our Discord. It is here, join our Discord server. So if you go there, you land on the Ars Nano Discord server. So if you have any suggestions, or want to discuss anything, or if you want to help, join the Discord server and let's chat. Or yeah, let's see next week, Tuesday, same time, same place. And let's finish that next week. Guys, it was fun. Have a good one and see you then. Bye bye.